Hello, year 8. We're going to do something a little bit different today. There is going to be no questions for you to try because we are doing an experiment. During the course of this lesson, you will probably need to pause the video at various stages. I will give you an indication of when you need to do that. But we are going to do an activity that requires a dice. If you do not have a dice, I have put a link in to a web app that you could use. You could perhaps even find something similar to use on your phone. It'd be really, really useful if you can print out the sheet today. If that isn't possible, you will have to later on draw a table and you will have to produce a graph for me as well. So our experiment today is all going to be to do with rolling a dice. Now we already know that when we roll a dice, there are 6 different outcomes. Because on a standard die, we have the faces that are 1, 2, 3, 4, 5, and 6. Now we're going to be collecting some data and working out some experimental probabilities, and those experimental probabilities are called relative frequencies. So relative frequency is a probability based on an experiment. So I'm going to take a little bit of time to explain the experiment that we're going to do, how we're going to collect that data, and how we are going to use that data. So I'm going to be rolling a dice 100 times and collecting some results. The way that we collect these results is quite important because we are going to be doing some calculations using these results every 10 throws. So first process I'm going to do is explain how we're going to collect the data, and then later on I will explain the process of calculating the numbers that we need. First of all, you need to decide a favourable outcome. And what I mean by a favourable outcome is, what do you want the dice to land on? What are you going to measure as being a good result? Now you can pick whatever number you want between 1 and 6. I think I'm going to pick the number today. Let's have the number 3. So my favourable outcome is going to be the number 3, and I'm going to be counting every 10 throws how many times I get a 3. Now I'm obviously not going to make you watch me do this for all 100 throws, but I'm going to explain it for sort of the first 10, the first 20, the first 30 throws, so you get the right idea. Now if you have a dice, that's great. I am using a dice app that I have found on the internet so you can see my rolls and I'm not fixing the results. So I'm going to roll this 10 times and I'm going to be looking for how many times I roll a 3. So I will do this reasonably quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I saw 1 3 there. So what I'm going to do in my table, and you could do this as you're going along if you wanted to. Okay. I had 1 favourable outcome, 1 that landed on a 3, and 9 that didn't. So that was 1 good one and 9 bad ones. I'm now going to do the same for the next 10 throws. So again, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I saw 2 good ones that time, so I had 2 favourable and 8 unfavourable. Now, I'm not going to write 2 and 8 here because I want to do something called a cumulative total. So altogether now, I've had 3 good ones, and if I had 8 here, 17 bad ones. These numbers should add up to 20 because I've now done 20 throws. Let me do another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, I counted one good one there and 9 bad ones. So I am up to 4 and 26, 30 throws. Now, obviously, your results will not be exactly the same as mine because you're rolling your own dice. So don't just copy the same results as me. I'll just do it one more time for the next 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I saw 1 there. So again, 1 favourable, 9 unfavourable. So I'm up to 5 and 35. So what I'd like you to do is complete this for your 100 throws, and then in my second part of the video, you will see the calculations that we need to do. So here I am, having now collected all of my 100 results, and I'm going to work out some relative frequencies. So again, just check that on your final row in your table, you have actually done this correctly, and your 2 numbers here add up to make 100. So your numbers here and here add to make 100. That is another check that you've not done any mistakes in your cumulative totals. Okay, I brought a calculator along with me for this because I might not be able to do every single calculation in my head, but also if we do get some nasty values on our calculator, we're going to round to 2 decimal places. So we are going to work out some relative frequencies. And the way that we work out the relative frequencies is we are going to do our number of favourable outcomes or our unfavourable outcomes divided by how many throws we'd had up to that point. So for example, for me, and again it might be different for you, for this point here I have done 10 throws and had 1 favourable outcome. So that is 1 divided by 10. And I know 1 divided by 10 is 0.1. Similarly, for my unfavourable outcomes, it is 9 divided by 10. That is 0.9. When I do my next row in my table, it is now after 20 throws and I've had 3 out of 20. So I would type into my calculator 3 divided by 20. Which I know is 0.15, and 17 divided by 20 is 0.85. And what you might notice about each row is they add up to a total of 1, because favourable and unfavourable are mutually exclusive. These are the only 2 things that can happen, so they have to add up to 1. Okay, now at this point, after 30 throws, I've now had 4 favourable outcomes. Now this one isn't going to be a particularly nice number as I type it into my calculator. So if I press 4 divided by 30, 4 divided by 30, press equals. Yes, on my calculator, the mode that it's in, it's giving it as a fraction. If I press the S to D button, you can see it's 0.13 with a dot on the 3 saying it's recurring. So that to 2 decimal places is just 0.13. Similarly, this would be 0.86. 40 throws, I'm now doing 5 divided by 40. Again, I think that one's a nice number, 5 divided by 40. I think it's 0.125 because it's an eighth. It's 0.125 and 0.875. 35 divided by 40. So what I would like you to do is fill in all of your results for your table. And when you've completed all your results for your table, you may join me in the third part of this video. So you should be at the stage where you've now completed all your results and calculated all your relative frequencies. What we're going to be discussing now is how you can produce two line graphs to represent what is happening in your experiment. So here is my set of axes that I'm going to use. You'll see that I've done my relative frequency on the vertical axis going from 0 to 1. On the horizontal axis, I have got the number of dice throws, and we're going to see two line graphs here. The two line graphs are going to represent one for your favourable outcomes and one for the unfavourable outcomes. And I'm going to show you how to plot one of your lines, and I will leave you to plot your second line yourself. So, going back to my results, I can see if I'm going to try and plot my favourable outcomes that I had a relative frequency after 10 throws of 0.1. So I'm going to plot 10 and 0.1. We plot with a cross rather than a blob. After 20 throws, it was 0.15. So 20, 0.15. 30 was 0.13 for me. Now 0.13 we are going to have to approximate. Well, if that's 0.1, that's 0.15, 0.13, about there. So I would like you to keep plotting your points for your favourable outcomes, and I would like you to then join them up dot to dot. Don't join anything back to the origin, so it will only join dot to dot from your 10 to your 20 to your 30 all the way to your 100. Do that in one colour. When you have completed your graph, I will show you what my graph looks like. Can you do this for both your favourable outcomes in one colour, your unfavourable outcomes in another colour, and remember to include a key? So here is my finished graph. I've labelled, I've done my key, and you'll notice that I've got my favourable and my unfavourable outcomes represented as lines. Now there's a few interesting things to spot on your graph, and again this will be an indication that you've done a reasonable job today. Now first of all, your graph will not look identical to mine, but it should look actually quite similar. And where it should look quite similar is towards the end of your graph. Okay, it might be a little bit different at the start, but I would hope that yours has settled around the same value as mine, and we'll talk about why that is in a short while. Now, one of two of you might have spotted that your two lines are actually symmetrical as well. And the reason that goes back to the fact that these two events are mutually exclusive. In other words, the probabilities had to add up to 1. That means if this increases by a certain percentage or a certain probability, then this would have to compensate by decreasing by the same amount. And that's kind of why you get this line of symmetry at the 0.5 mark. But what I'm really interested in is a final conclusion. So can you make sure that you use the last few minutes to conclude using the sheet that you have printed out, or just write this into your book, please. Okay, we are now just going to try and link back to what should happen in theory. In other words, what we think should happen, as opposed to what happened in our experiment. The probability of my favourable outcome was a 3. You might be writing a different number there. And we know that when we roll a dice, it should be a 1 in 6 chance of that happening. My unfavourable outcome would be not 3, and that would be 5/6. Okay? Now, if you turn 1/6 into a decimal, let's bring our calculator up to do that. 1 divided by 6. What you'll notice is this equals 0.16 recurring. Now, 0.16 recurring to 2 decimal places, because it would be 0.1666 going on forever, would round up to 0.17. Similarly, 5/6 is 0.83. Now, how does that compare to my results? Well, I'm just going to go back a few slides and bring up my table of values again. If we look through my table of values, my numbers aren't very close at the start. But by the end, to 2 decimal places after 100 throws, and this might not be exact for you, I just perhaps got a little bit lucky, I've got exactly 0.17 and 0.83. So how do my results compare? I'm going to put my results were almost perfect. Wasn't at the start, but it was by the time I'd done 100 throws. Now, why is this important? The reason why I wanted to do this experiment today was to try and give you that indication of the more times you do something, the better the results are. So if you think back to last lesson, we talked about someone who'd done an experiment or was estimating a probability over more results had a better conclusion. Well, what we've shown here with our line graphs is the more times we rolled the dice, the closer we got to what should have happened in real life. In other words, those theoretical results. So the more times we repeat an experiment, the closer the results should be to the theoretical. So make sure you've got those conclusions written down today. It will be great to see some images of your graph and perhaps your table to go along with today's lesson. There are no further questions. That is it. I hope you enjoyed this slightly different lesson. If you do have some questions, of course, ask in the Ask the Teacher channel.